All right, to kick off our second chapter, we're going to be talking about measurements. So, an important question then is, well, why do I care about measurements? And that's because you're going to be taking a lot of measurements. This is how we gauge where our patients are in their healthcare journey. So, some measurements that we can take are things like distance, how far something is, or measurements of time. How long, we can take measurements of mass. How much do we have? Volume, how much space does it occupy? We can even see things like pressure, how much force, as we take some of our measurements. We can a couple of other really common measurements that are taken, especially in the healthcare industry, and right now with the COVID-19 pandemic, is temperature. And so when we take a look at these, there's kind of the standard unit that we'll see and some really common units that we'll see with it. So what we're going to do is we're going to take a look at two different systems. The first system that we're going to look at is called the SI system. This is the international system. Or the international standard, maybe. And so these are the units that you would see published in a like a commonly accepted journal. So in this case, when we take a look at our SI units, we'll see that for each of these are going to be a little bit different. If I take a look at the units of SI, I'll see that distance is often measured in meters. And we'll see meters are abbreviated with a lowercase m. Standard for time is a second. And you can see this abbreviated as a lowercase s. And then just for my notation, you can also see it written as an SEC. When it comes to mass, our standard unit is a kg, or in this case, a kilogram. We'll see volume is commonly measured in cubic meters. So we'll see that that's a meter with an exponent of a 3. The standard of pressure is a bar. And there really isn't an abbreviation for that one. That's going to be standardized as it is because it's a short enough unit. And we'll also see that for temperature, our standard is Kelvin. And you'll see that abbreviated with a capital K afterwards. So there are some other common units that we can see too. And we'll normally see that these are common units we see inside the metric system. So when we and we'll see that some of these SI units are the same units that we use in the metric system. So in this case, we'll see that we have a meter is the same thing with our seconds. However, when we take a look at the metric system, we'll see that mass is commonly done in kilograms, which I abbreviate as a lowercase g. And when it comes to the standard of the metric system for volume, we measure in the liter, which is a capital L. Pressure is normally done in an atmosphere. And lastly, we'll see that the standard is a degree Celsius. So we'll see that there are sometimes some different units that can be used to measure the same pieces. So as a quick review, distance measures things like how far. Time measures how long. How long did it take? So kind of like in the sense of duration. Mass measures how much matter. Volume measures how much space. Pressure measures how much force. and temperature measures how much energy. And there are fancier definitions for each of these, but this is kind of the big takeaway that I would like to see from our course. And what I'm going to do is I'm going to add one more column over here. I'm going to shrink this down just a little bit more. There we go. And I'm going to kind of place here in blue all the way at the end some other common units. And we'll see things like millimeters. We'll see things like centimeters. You can even see things like feet and inches if you're talking about the empirical system that we use here in the States. When it comes to time, you can also see that this is expressed in hours and minutes. We'll see grams can also be expressed in kilograms and grams. That's really the two biggest metric common units that we're going to see. When it comes to volume, we'll also see that things are expressed in milliliters or deciliters. Pressure, on the other hand, has a little bit of a difference. We'll then see that we can express this in torr. We can express this in millimeters of mercury. And then lastly, we can also see that for the standard system, we can also see that there's a degrees Fahrenheit process as well. So as we're looking at some of these systems, I want you to start familiarizing yourself with these units. Now, there are a couple important key equalities then that we need to follow up with regarding some of these. So if I were to say things like, well, I have a meter, but how many millimeters is a meter? These are some important things to know. And so what we'll do is we're going to take a look at some of these abbreviations and represent what they mean. So, for example, when we take a look at the metric system, everything is based on a power of 10. And so that means I have things like 10 centimeters in a decimeter, 10 decimeters in a meter, 10 meters in a decameter. Everything's based on increments of 10. So, for example, we'll see that we have normally things like our base unit, and for an example, we'll use like our meter as a base unit. And so this will kind of be what we call 1. As I move up this chart, we'll see that we become smaller. And as we move down this chart, we'll see we become larger than 1. So with our base unit then, I think we'll have to go just a little bit further. There we go. So as we go smaller than 1, we'll kind of start from 1 and work our way small. So this is the base unit. And what we're going to do is we're going to take a look at the prefix and then how to abbreviate that prefix with a unit. So for example, as we start working our way down, the first one we're going to see is a deci. And this is the prefix that goes with it. And I abbreviate this with a lowercase d. So if I were to have a decimeter, I would combine my prefix and my base unit to make a lowercase dm. This is the same thing as talking about my 0.1, which can also be written as times 10 to the minus 1 instead. So that's how we write that in scientific notation. As we start working our way down, we'll see things like centi, milli, and these are probably things you're familiar with. But we are going to have to go just a couple units smaller. There we go, get our full equalities written out. So now, when I'm here, we'll see that as I go the next unit down, we're going to jump by a factor of 3. I'm going to go down to micro. We're also going to go down to nano. So when I look at micro, I can see this abbreviated one of two ways. Kind of like a fancy U or the Greek letter mu. You can also see this abbreviated as an MC. So if I were to give the unit of a micrometer, I would write this or MCM, one of those two. And this is the same thing as 1 times 10 to the negative 6 meters equals 1 micrometer. I'm not going to fill in all the zeros because that's too many to write. And then I'm probably going to do it wrong if that's the case. So what we'll do then is we'll then take a look at our nano, which is abbreviated with the lowercase n. And I start looking at nanometers. I'll use a lowercase nm. And I know that 1 times 10 to the negative 9th meters is the same thing as 1 nanometer. So these are the ones that I want to keep you accountable for going smaller than 1. What we're going to do is we're going to take a look at the values that then get larger than 1. So as we start to get larger than 1, we'll see that we have our ones that we're familiar with: deca, hecta, and kilo. And you probably learned something like King Henry died drinking chocolate milk when you were going through school, right? And it covered from milli to kilo in the metric system. So when we talk about deca, now I'm going up. So my decameters, I'll use a capital DM to abbreviate that. And I know that 1 decameter is the same thing as 10 meters. Or you could say it as 1 times 10 to the first meters if you're sticking it in scientific notation. As we keep going, we'll see we have our lowercase h for our hectometer. And I know that 1 hectometer is the same thing as 100 meters, or 1 times 10 to the 2 meters. And then on our last one for kilo that we're familiar with, we'll see things like this would be a kilometer, the km. And I know that 1 km is the same thing as 1,000 meters, or 1 times 10 to the 3rd meters. So the two new ones that I'll expect you to know are going to be the mega and giga prefixes. You've probably seen these with things like data. So we're going to have a capital M and a capital G. And so I would call this a megameter, capital M, lowercase m. And 1 megameter is the same thing as 1 million. Or, I'm just going to write this right out in scientific notation, make this nice and easy. 1 times 10 to the 6 meters. And then lastly, a gigameter. This would be 1 gigameter is the same as 1 times 10 to the 9th meters. So as you use the metric system, you'll notice the power of 10 changes depending on what your prefix is, and you can help indicate the scale of a measurement. Instead of having to adjust a bunch of zeros and really small numbers, you can choose to use a prefix instead. So in the next video, we're going to use some of these prefixes and conversions to see how we can set these up and apply these to some measurements that we take. So stay tuned.